The last event for today is actually a panel discussion with several of the speakers from earlier today. So if you can all come here to the front. And we're also going to be joined by Robert Brennan from Open Hand as well. So Robert, if you can come to join us in the front as well. Why don't we pull some chairs? So we're going to get some microphones in a second. But yeah, the goal for this final panel session is to have a little bit of an opportunity, both for more questions from the audience, but also we've heard a lot of different perspectives today, and I think it will be interesting to hear some discussion among the presenters on some of the things that have been discussed today. So, for example, one of the things that I think has been a common thread in a lot of what we've heard today is the speed with which a lot of this technology is developing, right? I kind of talk about very old history, but the fact of the matter is that in this field, a lot of times 2024 feels like very old history. And I'm curious about how in some of your different research efforts you're dealing with this super rapid rate of change, and the way in which sometimes there is this worry about is the stuff that I'm doing today going to be at all relevant 6 months from now?
So one answer is well, you can work 6 times faster than you were able to before due to the advances in our field, which also makes it a little bit exciting. But I think it's interesting and tricky because you do need to kind of think pretty deeply about, what is the world going to look like? If you're talking about like the scale of academic research, you need to think a little bit about like what's the world going to look like in 1 year, 2 year, 5 years from now, and what can I be doing now to make that look better? And specifically, what unique insight can you bring? What thing can you do that's like different than what everybody else can do, and stuff like that. So I think it's tempting to watch your agents work all day, but sometimes you need to also go out and take a walk and make sure that you're like focusing on the right things.
I'm going to share some perspective from our educational research. I am not a programmer, and so some of our work is building educational technology and to be implemented in classrooms and in schools. And we have tested out using LLMs for conversational agents to be used in a classroom, whatever the setting is. And we have tested out in kind of group team building exercises because we are valuing human skills, because that is even more needed now than ever, I would think. But one thing we noticed is that because the models are rapidly changing and they keep rolling out new ones that are even more and more advanced, even with the same pre-prompt and the same context, and we do all of the prompt engineering that is recommended, that is the way we're supposed to. We set a persona, we set very good constraints and context and clarity and everything. And the agent actually behaves differently when it's a different model. And with the speed at which the models are advancing and changing, it becomes a question for us in educational research in terms of, can we even roll it out and can we even implement it in a classroom? Because by the time it has gone through rigorous testing that we believe is safe enough and good enough to be used in a classroom, it's a new model that's out now. And then we will have to then do all of the testing again. So when will it actually be ready and safe to use for students in a classroom? So that's one of the challenges we're facing right now.
Yeah, I think one of the things that's tricky is that there's kind of two two waves of innovation, one following the other. You've got the core language models that are improving very steadily over time, and then you have the human interfaces that are always like trying to catch up to the model. And I would say even if large language models like froze today, we would have years of work to do to like really get all the value that we could out of them. But they're changing every 3 to 6 months, and like it's just this. You're constantly chasing, what's best, and we're getting, 25% of the way there, 50% of the way there of what's possible before like new possibilities start emerging. So it's definitely a treadmill of a race.
I'm not sure if I have such a clear answer to that. If I think about what we are doing, the typical question at some point always becomes like, can Anthropic not also do it? And they have a lot of resources. They have a foundational model in the end that can fine-tune, train, retrain in other ways. It's an immense advantage for them, which is simply out there. So I think like even building companies around that space right now is very, very tough to compete against the really big ones in the long run. Because if something really works out, what would prevent them to just not take it? And the field is moving so fast. I think research-wise, it's a little bit easier because you can always still have good ideas and they just pick it up, by the way, right? Which is a success story. It's a form of having impact. And so this is a little bit my stance on that right now. I think there are some opportunities, particularly if you position the things the right way, like things which, like, for example, we have a lot of knowledge in certain types of systems. It's like if you build ontologies around that, there might be a really edge up if you do it correctly. But it's not easy.
So, I have been in the programming languages / programming system space for probably 20 years. And one of the things that has characterized the field for a long time is inertia. Right? People really like to keep using the programming tools they've been using all along. If you have a new programming language, a new programming tool, you basically have to wait until the people who are learning that language and discovering it as undergrads, move through the pipeline before it will really start getting adopted in industry. But today, it seems that there's a real openness, especially from industry, around adopting the latest and greatest programming technology. And I'm curious, I think a lot of you have a lot of contact with industry. And I'm very curious to hear your perspective around, how maybe industry sees some of these, the adoption of new programming tools and programming technologies, and is it different from what it has been before?
Yeah, the developer inertia is definitely a big struggle, right? There's a reason that autocomplete was the first AI tool to get real adoption. We've been using autocomplete for decades, and it just got 1,000 times better with LLMs. What I would say is we're really seeing increasing divergence between what your median developer is doing with AI versus what the top 1%, top 5% early adopter is doing. The gap between those two personas is expanding over time, which tells me that this technology is still in its infancy. I would say increasingly we're seeing within industry this new persona emerging that we'll call like an agent engineer or an agent orchestrator who is doing much more than just like pair programming with Claude Code on their laptop. They're building automation that uses agents under the hood to do, if you're pair programming with Claude or the OpenHand CLI or whatever it is, you probably get like 20, 30, 40% productivity boost. But for certain like very repeatable tasks, very automatable tasks, we're seeing literally like a 2 to 30x boost in productivity by just doing like full automation using like pipelines with agents running under the hood. So there's like really amazing stuff that's possible if you're willing to like invest in these like very new, very strange and kind of foreign workflows.
Yeah, and like one thing I've also noticed is like there is a pretty big difference. Like I don't how many people program? How many people use like something in your IDE? Like AI in your IDE, and how many people are running like 3 to 4 agents all running at once? So like you see, there's a pretty big divergence even with the people in this, audience about the way that they're using things. So I think there's definitely like a lot of, uptake of the new technology, but it's not immediate. Yeah.
we'll share some insights from Pathways for AI Training and Hiring, which is a new initiative project that's with Cynthia Brazil from Media Labs PRG and Eric Loffer from Scholar Teacher Education Program / Education Arcade as the PIs. And for part of this, we try to understand where industry is coming from in terms of the next set of hiring and what they need in the workforce. So some of my colleagues have been conducting industry interviews, and it's interesting for us to hear like how much that some of the industry companies we are speaking to are actually looking to upskill their own workforce, not just like hiring people with those skill sets, but for the hiring of the people who are new to their company. There are at least some companies who told us that it would be irresponsible for them if the candidate doesn't know how to use AI, because there is that assumption that people coming out of colleges now have that particular skill set and competency. And yes, they are looking into upskilling their current workforce on some of these newer technologies as well. So that is one of the more consistent messages we are hearing from industry so far.
So I also want to open the floor for people in the audience who want to ask questions.
So a lot of the concentration with AI tools has been on how to make things more productive, how to produce more code faster. Since you're looking ahead, what do you think about the improvement of quality, which has, of course, been a huge problem in software for many years? And, you know, will the quality get better? Will we get faster systems produced that work better for more users? Will formal methods that are able to show better quality be able to be incorporated, and so forth?
Yeah, it's a great question. I would say, you know, while we're in the early days, I would say quality went down while you know, quantity went way up. I think we're getting much better at working with the like sheer volume of code that AI produces. You know, Graham talked a little bit in his presentation about the verification problem, which is something that many researchers are focused on now. You know, how do you, once the AI has generated a bunch of code, how do you validate that the code is good, that it does the thing it says it's going to do? And I think that's a really interesting area of research right now, and one that I'm very interested in. And I'll say too that we're seeing increasing usage of AI specifically for enhancing quality, so improving test coverage, for solving security vulnerabilities, basically doing all the maintenance work that goes into a code base to like keep the lights on, keep dependencies updated. Those are very automatable tasks, and increasingly folks are looking to AI to just do those code-based quality improvements that don't really land on your roadmap. That they're not going to like, you know, get you new customers, but always like keep your code base healthy. I think that's actually a really great use case for AI, maybe better than the ad hoc feature development that we're used to.
I'd also like to point out that one of the things that is like most popular in like our company OpenHands now is getting the agent to read all our error logs and go fix the issues that we have in production. So like you can have it browse through all the logs and then find the place that's causing the error and just send in a PR and fix it. And like 90% of the difficulty in doing that is not coding. It's like actually going in and understanding and localizing the problem. But actually, LLMs are really good at doing that, and most programmers don't like doing this. So I think there's actually a pretty good potential to really improve software reliability by doing all the things that programmers typically don't want to do and they don't get like raises for doing, but like are really, really important.
I think for the first time you can actually like really get good test coverage, much better than ever before. And because like nobody actually likes to write tests, and if you know many software out there, like you always forgo the testing part a lot, And then you get this like at Amazon, they call them patch blockers, which is like this whole thing where tests fail and they constantly fail and nobody really fixes them, right? And they're always a good reason while you even deploy, even though the tests fail. Right? And I think this whole part now suddenly you can address in a complete different way. And that's like one of the things which we heavily look into. How can you create a test-driven approach to software development like that? Everything is test first. They work all the time. They are correct. You focus a lot of time on that part, which also then helps with like the code itself, right? That it's correct. And this is not just like the generated test. It's also the whole environment you use for that. Like that you can do integration tests, parallelization, like fuzzing, and a whole bunch of other things.
So about 10 years ago, there was a big push from the programming systems community on automatic bug finding, right? And automatic tools for automatic bug discovery. And I remember being at a workshop, and somebody from industry got up and basically said, like, why are you guys doing this? We have an entire database of bugs that real customers, right, real people using our software have run into and reported. So I don't need a tool that goes and tells me that my software has bugs. I know my software has bugs, right? Go build me a tool that fixes them. And I think it is exciting that now, for the first time, we have the tool that fixes them.
Yeah. In the past, there was a push to formalize software specifications, and in the 80s and 90s, and come up with executable UMLs and all those kind of things. But now that all seems to be thrown out of the window, and we're going back to natural language with all its ambiguity in trying to specify things for the AI to write. Why not have a push back to like have some formal representation of the software that the tools can probably do a better job generating code that's less buggy? I mean, what's happening with that effort?
Like the short answer is, have you ever tried to write a formal verification thing for anything? This is often way harder than even writing the code for it to get a concrete instance, right? Like it's like if you really would do the formal verification as the starting point, it would slow you down like crazy. I think, and Armando and I, we chatted quite a bit about that in the past, and I still believe there is a place for formal verification, but I actually think it's generated formal verification code, and he has like some really cool results on that front as well. So I actually almost say like, Armando, you should take that.
And I don't mean formal verification or a formal specification that goes through a formal verifier, but something that somewhere that a specification of the software, what the software is supposed to do, that's unambiguous, kind of.
Which at some point becomes code if you really put it down to the level, right? Like it's very hard to find the right level of abstraction. We just say like we have it in natural language because in the end our ontologies by now at some point we are even going further than that because we don't even need natural language anymore. So we need the right tokens so that the LLMs produce the right code, which is again slightly different. But nevertheless, like I think there is you want to find a ground where it's like specific enough, but maybe still very easy to edit for whatever you are after. And in the moment you have a really detailed description of everything, this thing becomes horrible to read. It might be like really specified in every aspect, but just like it's not easier to change or edit than code.
I will say I am seeing an increasing push towards spec-driven development among engineers, so much softer and squishier than any kind of formal specification, but
I really hate the word spec for that. Like what spec-driven development is right now has nothing to do with a spec. Like,
yeah. But I think the sorts of engineers who previously would have just like started putting hands to keyboard and churning out code are now spending hours before starting a project really listing out like in a markdown document, here's what I'm going to do, here's what the code should look like, here are the parameters that are going to be involved for this function, et cetera. They're using AI to kind of pair on that, but then they have this document that describes exactly what they want done, and they're able to feed that into the AI and get a very like clear result out. That seems to be a good workflow, kind of a middle ground between something super formal and just like throw a 2-sentence prompt at the AI.
I do think that there is a big opportunity in the use of AI for truly formal, fully verified software development, but I think we're not there yet, right? I think that's the whole other mountain that we have to learn how to climb. And this style of development doesn't make sense for everything, right? Not everything deserves to get that level of attention, right? But certainly if you're writing a hypervisor, right, or you're writing the kind of code that absolutely has to work correctly, or the security of your entire organization is compromised, then it makes sense.
So most of what we've heard today, I think, falls into the category of a server in a rack processing data that are already available in various other servers and other racks. But it seems like there's a lot of uses for AI that would have to be done with additional data from the real world and run on much simpler machines. So I'll just give you a couple examples. Somebody tells you that go to the store and buy these 6 things. Your phone overhears it. It'd be nice if the phone kind of notices where you go in the store and that, hey, you forgot to buy, you put 5 of those things in your cart, but you forgot that 6th thing. Or if you make some coffee, when you get to my age, I make the coffee, and then 2 minutes later, I'd really love to be able to ask some machine running locally in my house, looking at images from video cameras in the house, say, hey, where did I put down that coffee that I just made? So can you speak how soon before all these, before it gets really easy to make AI systems that interface to sensors in the real world, like cameras, and where, for privacy reasons, the data don't have to go all the way up to an H200 board somewhere in the cloud?
Yeah, I can speak a bit to this. So right now, I talked about how we're benchmarking some systems at the moment, and hopefully going to release something about it next week. We're also looking at locally runnable models, and these include locally runnable models that have 480 billion parameters, and so those are not ones that you're going to be running on your cell phone. But we're also looking at models that have 30 billion parameters, which can run on a, for example, NVIDIA DGX Spark, which is this big and can sit in your house. And on Swebench, which everybody's tired of hearing about, they're actually pretty similar. They're not, the smaller models are not quite as good, but they're quite good. I think the place where they really drop off is their generalizability. And so you try them on things that are not directly within the target that the language model training company was aiming at, and you get it just doesn't work as well. It doesn't follow instructions. It doesn't have the perception. It doesn't have the other things. But the good news is these are very trainable. So if you are able to come up with a training data set that you can somehow find somewhere on the internet that matches your thing, you can fine-tune it to be better at the things you want it to do. And so I think in the truly locally deployable case, especially deployable on not large hardware but small hardware, that will be an interesting challenge for 2026, I think, where we're going to be able to come up with data, also maybe be able to come up with synthetic training environments where you say, this is what I want it to do, and it generates an environment, and then the model goes and trains itself on that environment on the cloud or something, but then you can download it and run it locally. So lots of interesting problems.
For us, it's a little bit different in the end. I'm going after the biggest and best models we can get at that moment in time. In the moment you talk about enterprises, it almost doesn't matter on how much the cost is, because we still save a lot of money if we use even the most expensive models. That said, I think the smaller ones actually are interesting for latency reasons. And that starts to matter more and more. It's the development process, which even the code completion, it's so nice because it immediately happens. Now, if you have something like OpenHand running X agents, it's just it doesn't immediately happen. It takes minutes, right? If not hours. So that's a point where like smaller models sometimes might be nice. So at least that you get a quick first attempt at a problem, see where things are going, where clarifications might be needed, and then maybe you switch to the more expensive ones and let it run, and hopefully it completes.
Yeah. I just have a side comment about latency, which is interestingly, there's really fast serving hardware now, like for example Cerebras, where basically the generations are instantaneous. And actually then the latency starts to be on the like execution environment, like executing the code, executing any programs it's running, and especially like executing unit tests and verification and stuff like this. So one bottleneck in development nowadays is not how quickly the agents can work, but how quickly your CI finishes, like your continuous integration finishes. And so I think there's also kind of like interesting, things about, okay, well, if we have agents that are really, really fast at writing code, how can we optimize the speed of the whole development process as well?
Okay, I'm really glad to hear that there's a lot of interest now in test generation and verification, because I think the world really needs it, especially in control systems. I mean, you hear about crashes on subway systems, and at the same time, people are talking about self-driving cars, whereas they can't even get accident avoidance on essentially one-dimensional railway systems. But I was also thinking that there are a lot of places where you can put additional tests in code and people don't do it because of performance or efficiency reasons. And as you get more and more complicated ways of putting more verification to make code safer and more reliable, it works in the small, where if you have a small thing that's not run that much. But what about for really large systems where you have execution, speculative execution, or where you have multi-threaded tasks that have to be coordinated, getting those correct, where you have a lot of performance issues, for example, congestion control on the internet, or other very large computations that run for hours. How do you handle that trade-off? And also, what about hallucinations? Is that still an issue where you change one pixel in a image and it's interpreted as an airplane instead of a pig kind of thing? Do you run into anything analogous when you're generating software? What are the problems and issues with doing this?
I'm not sure if I really understood the first question. Is your question is like if you have too many test cases on how you can deal with that, or like I'm not sure if I got the first part. The second part, the second part about the hallucination, like it still happens. I'm not sure if I always would call it hallucination. Like at least in the ones we encounter, it's more like LLMs are really, really good to pick a good default, and sometimes the default is something completely not what you have in mind, right? And it just derails you a little bit, and then you need to correct it. This we see all the time. There are weak points of models, very clearly. Like I mentioned the concurrency issue, which is one of them. Concurrent code is still more problematic than if you have something single-threaded running. But this can be fixed, and there are other weak points. And the nice thing is, as more you develop one, you see the weak points, and then you come up with strategies to mitigate them.
And do you have models that you can use to generate the verification so you recognize that this has happened?
What happened? That there's a problem in the code? Yeah.
Well, that you've chosen something that's an analog of a hallucination that doesn't do.
So, for example, the parallelism issue, we generated code, like first the test cases. The test cases were done in a way that we had parallelism in mind. And then in the moment the code was generated, we figured out like, oh no, this is like not working at all. And then we had to step in and fix that accordingly. And it's like, but this was both a manual process. If you just ask for the test, unless you specifically say you're testing for a parallelized environment and there might be race conditions, it probably wouldn't have even generated the right codes, right, for it.
I can talk a little bit about like hallucinations. Like I don't think it's like super well defined, but there's a bunch of different things that are close to what we would call a hallucination. So like one is that it uses like a function that doesn't actually exist. That one's super easy. You just run the code and it doesn't work, and then it goes and fixes it. So that's essentially not a problem if you're using an agent to be coding, I feel. The more difficult ones are it does a very surface level analysis of what the problem is, and then it quote unquote solves the problem by bandaging the solution, but not solving the actual solution, not solving the actual problem. I would maybe call that a hallucination in that it's thinking that it has like actually solved the problem, but it hasn't. Another version is it will say it did something when it actually didn't, and that it happens relatively frequently, even with the stronger models. So there definitely are problems. So I think that's why, like, you know, number one, human verification is important, but also you can always ask another agent or another model to do like a second pass over the code and make sure that it looks reasonable. If you have a way to ask it to like test that it actually worked, like one thing you can do if you're doing front-end code is you can ask it to take a screenshot and show you the screenshot. And then it will try to take the screenshot, realize it can't take the screenshot, and then it goes and fixes the actual problem or something. So there's a lot of these kind of like dark art style techniques at the moment that I think we need to systemize better. And ways we can systemize them are by training the models to be better at doing these spontaneously, and also prompting the models to kind of like push them in the direction of doing this, or engineering the whole system so it makes it necessary. So like you can't submit a pull request unless you upload a screenshot.
Just as one addition to that, like the only thing is just like the models are getting so quickly so much better. I still remember like 2 years ago, we started working on this, and one of the biggest things we had issues was like that if you have, let's say, two interfaces, one is called page, the other one is called page implementation or page impl. It was mixing the two up. It never figured out which ones to use. Even if you instructed which one to use, it confused them. That problem, for example, entirely went away. Right? And so now with the right instructions, it actually follows them pretty accordingly. So it's very interesting. I'm not sure if this is hallucination in itself, right? Because you picked the wrong object in some way. But it's amazing how quickly these things got better. And we fixed the previous one by giving them very distinct interface names that fixed it for the time being. Now we don't need that anymore. So that whole thing went away.
I'll go back to what I just mentioned, though, because models don't get better. People make models better. So I think the people who are making the models better are working very hard on solving these problems through pre-training, post-training, reinforcement learning. And so that's like the first segment. I think prompts are more of a temporary patch around that because, you know, like those people have not done their job well enough, and so then we can put prompts around them to fix it. But eventually, you can keep in mind that you're going to be able to remove those prompts if the models are trained in that way. But I think also like having programmatic verification is not a bad idea as well, especially if it's things that, you know, it'd be a huge pain for humans to actually verify as well. Like the fact that all of your test cases pass still makes sense to run tests. So, yeah.
Hi, I have a question about how all of you kind of see the future, not the future where the AI model is actually making the next AI model without the humans. That's a little farther, so something a little closer than that. And I've tailored it a little bit to each of the panelists. So for the panelists from all hands, like how do you see the future of like, Sam Altman has talked about like the solopreneur, like the one person who sits there and like creates a multi-billion, trillion-dollar company here. Trillions now. So that's kind of the future. I'm curious about how you guys see that. In terms of the ontologies for G5, like so the representation of the actual, like so the ontology you choose probably is important, right? Like there's some that are better than others, right? Like so how do you pick the ones that are better than the others, or does it even matter as long as it gets the job done? And like are there still the people who care whether this like representation is better than another? For example, like Maxwell's equations, right? We have like all of E and M distilled into these 4 beautiful equations. But there's a more even beautiful system if you use Schwarzman algebra as explained by Hestenes, which does it in one formula. And the entire representation underneath that is like just even much better. So that representation is so much better, but doesn't matter, right? If you do the same things with a different ontology, like when does it matter whether that representation is different? I guess that kind of brings me now to the learning part, where like, as I'm learning these things, how many years do I need to learn these things in order to appreciate the beauty that I can do things in these 4 equations versus like 1, right? I have to spend years and years and years more. So like, how does the LLMs change me over the process? And not just me, but in society with others. Like, I thought that might be a good question to hear from you. And then lastly, what will the world look like when all the software we get back is correct by construction? That's just like the only possibility. And what would that world look like? Okay.
Yeah. Take a crack at the first one. We got 4 minutes. I'll try and do it in like 30 seconds. The thing I'm more excited about than the billionaire solopreneur is more that we'll have custom software on demand. I think everybody's going to become a software engineer. They're going to be able to build, the social network that they want for their 20 friends on demand very easily, be able to maintain it very easily. So I think you're going to see this democratization of software rather than one person controlling a massive social network. You're going to see a proliferation of social networks that maybe interoperate.
I had a different question from you, but maybe I just add something to this one because it's actually more interesting. There are 2 things to that story on one hand. On one side, I actually see that software as a service companies, as we know them today, will all have a problem. Right? I already hear it right now by talking to friends from Accenture and other places that more and more people are looking into replacing software as a service subscription with self-grown software. And I think this will change an entire industry. And you actually see, I think right now, many of the SaaS companies are actually down in stock price. And I think it's part of the reason. Not entirely, but it's part of driving it. The flip side of that one is, and nobody could me so far give me a really good answer to that one, is, so I talked to another CEO from a big company here in Boston, and he was telling me, I was talking about this customized software and how quickly we can now do it, essentially pitching G5 to him and say, hey, this is the best thing ever. And his first comment was yeah, but we don't need more customized software. We need more standardized ones I don't have to worry about. Because every customized software you put into your company, you have to maintain as well, you have to run it, you have to monitor it, and all that stuff which normally the SaaS software providers are actually kind of doing for you. They patch it and so on. So it's actually quite interesting trade-off, and I hear both sides of the story right now. Right? So I'm really not sure yet 100% where we land in the end. That's my thought on that one. For the ontology ones, just yeah, they're better and worse, and you pick one.
From the educational perspective, learning, I thought of the analogy that people have used. I think Eric might have actually used it in a talk previously about when calculators first came out, and then there's a lot of argument as well, are people still learning math if they're not adding by themselves or subtracting or doing divisions and such by themselves when there is now a calculator. But fast forward a few years, that I believe starting in 5th grade or middle school students are using scientific calculators or even graphing calculators by the time they're in high school. So it allows people to learn and build on skills that were previously unavailable to students. But then on that note, I also see the other side of how important is getting that basic arithmetic down is. And if you are relying on using a calculator to do 3 + 5 when you're in 1st grade or 2nd grade or 3rd grade, then you might not gain that level of confidence in mathematics when you were young in order to do higher level maths later on. So there's kind of counter arguments to either side. So I think that analogy applies even now.
And regarding the future where everything is verified, right? So on the one hand, it is surprising to realize how much vulnerability there is in society just from random software bugs that somebody made a mistake and suddenly it's possible for an exploit to cost several $1 billion in damage to the economy, right? At the same time, it is important to recognize that, first of all, there's a lot of legacy software out there that is going to be very difficult to patch and maintain for a very long time. And, software security is a moving target, right? And every time you think that you've, closed a particular vulnerability, as the systems get more complex, right, the attack surface also keeps growing. So I think it could certainly be very transformative, but it's, there are limits to how much it will buy us.
Good afternoon, Gerson. I would say an engineer for the Media Lab, and looking at that spiral reminded me of I might butcher the name, it was like Fibonacci. Oh, hold on, wait. Fibonacci spiral, yeah. So my question to you that I had really quick was, when building AI tools, do you consider creators with intentions for AI to not be accurate, but to be a system that helps you relearn or teach a new skill? Doesn't follow instructions, but is trainable.
So the question is, like, are we considering like teaching AI
like
new
basically
skills,
using an AI creating an AI that artists can kind of create new ideas with, but it's not necessarily accurate to like a regular person or like a regular question, but more so like using AI as a tool to be a new artist, like a artist with an engineering background.
Yeah, so I think it's really interesting, like AI for creativity, and a fair number of people are thinking about this now, and one of the biggest challenges here is like, what is creativity, I feel? And like, I talked a little bit about training AI models, and once you can evaluate an AI model, you can put it in a reinforcement learning environment and train it to be better at doing that thing. So it's kind of like now our recipe for training AI models. But the problem is we can't really quantify creativity. And like a lot of the ways we come up with to quantify creativity, I can quantify creativity from a mathematical perspective, which is like, this is unlike anything that's ever been created before. But at the same time, it kind of needs to be good, right? Like I can come up with a random image that's just static, and that's going to be very different than any image that's been created before by some metric, but we can't, like, people won't want to look at it. So that's very nebulous, and so I think that's a particular area where, like, really human intuition about what is both new and interesting needs to get in there. But I think from the point of view of, like, idea generation, you can get an AI model to generate something that's really weird, by upping its temperature or like messing around with its generation parameters or something like that. The question is, like, will that spark inspiration in somebody that can then take it over the finish line and make it into something that's really appealing? So yeah, I think it's a really interesting space.
So I want to have Grace just do the final word on this, again, it touches on education, and then I think we're going to have to close for the day.
The pressure. I actually have heard of an interesting case where I believe it was in Dubai, where they opened up a number of, I think it was statues, opportunities for them to do public art installation at different places in Dubai. And I think all of the architecture firms that were, that entered it had to follow one criteria, which is to use AI to help them with the design and everything. And then it generated, from what I heard, it generated a lot of very creative, big C creativity thoughts about, or ideas that that was previously not really imagined prior to that. So I can dig more into that to see what that is. But there are pushes from the community, from even the art community, to see how that can happen. But then I think even the art world, when it comes to creativity, is quite divided in terms of what is considered what is considered like true art because of art that is supposed to represent the human nature and the humanistic, the humanity of things versus.
And you said this is in Dubai, correct?
This was, I believe, in Dubai.
Gotcha.
Yes.
Thank you.
Versus LLM, which is probabilistic model that generate things that may look like truth, but then might not mimics truth, but it might not actually be truth, which some people have other call it not so nice words about.
Thank you so much.
So with that, we're going to close our event for today. Thank you very much for all of you for being here. And just to remind you that this was the first event from our Expanding Horizons series, this IAP. There's more events next week that you can check out on the website. So thank you very much for being here, and have a great day.